Okay, everybody, welcome. We're going to be talking about a topic here under the realm of polynomials. We're going to be talking about multiplying polynomials. Our concentration is going to be on quadratics, although this will work for any set of two polynomials that you would like to multiply. This is also a topic that is under the realm of algebra. And so I want to begin by just discussing the two different methods that we're going to be using. I'm going to be using both an area model and by using the distributive property. Both of these methods work equally well. I really like the area model because it allows you to be able to organize your data, organize all of your terms, and in a very clean and easy route. So let's just go ahead and begin. So I'm going to start with this first example here. This first example is 3, which is a constant, times the binomial x plus 2. Binomial is just a fancy way to be able to say we have two terms here. We have the x term, which is a linear term, plus 2, which is the constant term. You notice here that we have this exact same problem. I'm going to be using a different method on the same exact problem on this page here. So let's go ahead and start with this first example. I'm going to begin by creating a rectangle. The length of the rectangle really does not matter because you're just going to do a generic rectangle. On this side, I'm going to put the number 3. That's going to represent that length of 3. I'm going to split this into 2 because I have a binomial going up here. This generic length here is going to be a length of x, and this here is going to be a positive 2. It is very important that you include the symbol with the number as you are multiplying. I'm going to fill this chart in now just like it was a multiplication chart. I'm going to multiply 3 times x, and I get 3x. I'm going to multiply 3 times 2, and I'm going to get a positive 6. The last thing that I need to do is I simply need to know that my answer is going to be the sum of these terms. So I can write 3x plus 6. Let's go ahead and move over now using the distributive property. Many of you guys will recognize this because we used this when we were dealing with linear equations, and specifically when we were simplifying linear equations or when we were solving linear equations. I'm going to begin by distributing the 3 to the x, and I'm going to get 3x. And lastly, I'm going to multiply the 3 times the 2, and that's going to give me a positive 6. You'll notice that the benefit of this is that there's a lot less work that's needed to be shown, although it can get complicated as equations get more complicated. The organization here is really, really nice, especially as things get more and more complicated. Let's go ahead and move down this page a little bit here and look at our next two examples. So here I have a binomial times a binomial. I have x plus 2 times x plus 4. I'm going to have 2 here and 2 terms here, and thus I'm going to be able to make myself a square. Mine tend to always work out to be a rectangle, but this is what we're going to end up doing here. So here's my square slash rectangle, if you will. Once again, it's a generic length, and so it really doesn't matter. I've given each one of these sides here 2, and so this length here is going to be represented with x. This one's going to be represented with a positive 2. I'm going to go ahead and put the x length x here and a positive 4 right there. When I go about and multiply this out, once again, I'm going to fill this out just like I did up above, a multiplication table. I'm going to multiply x times x. That's going to give me x squared. I'm going to go ahead and multiply x times 4. That's going to give me 4x. I'm going to multiply x times 2. That's going to give me 2x. And lastly, I'm going to multiply 2 times 4, and that's going to give me 8. You will notice here that I have 4 terms here. I'm going to go ahead and write all of those terms down now. So I'm going to begin by writing the sum of this, x squared. I'm going to write plus 4x plus 2x, and lastly, plus 8. Before I finalize my answer, I need to be able to clean this up. You will notice here that there are 2 terms in the middle that I can actually put together. And so I'm going to go ahead and copy down my x squared. I have 4x plus 2x, which is going to give me plus 6x. And lastly, I'm going to copy down the positive 8. I'm going to do this same method. That's my final answer here. I'm going to go ahead and do this the same exact problem over here, but this time I'm going to use the distributive property. You will notice here that I have two things that need to be distributed, two terms that need to be distributed. I first need to distribute the x, and it needs to be distributed across these two terms over here. Then I'm going to distribute the 2 as well. So I'm going to begin by distributing the x to the x, and that's going to give me an x squared. X times x gives me x squared. I'm going to multiply x times 4, and that's going to give me a positive 4x. I'm going to go ahead and change my pen here, although this is not required. I like the color difference here. I am done with the x, distributing the x, and now I must distribute the 2 to all of these terms. I'm going to go ahead and distribute the 2 to the x. That's going to give me a positive 2x. And lastly, I'm going to distribute the 2 to the 4, and that's going to give me a positive 8. Remember that we are multiplying here. Just like before here, you'll notice that I have two terms that need to be combined here. So these two middle terms are linear terms. It's because it's just an x here. I can copy down the x squared. I have 4x plus 2x, which gives me a positive 6x, and I can copy down the positive 8. Once again, you'll notice that I ended up with the exact same answer. Either method works equally as well. I'm going to go ahead and move this down. And up above here, we had all talked about polynomials that had leading coefficients of 1. You'll notice that they only had an x term in each one of them. And what I'm going to do here is I'm going to get a little bit more complicated. I'm going to have a linear term that has a coefficient of 2. I've also slipped in a negative sign to show you how to deal with a negative sign on this. So let's go ahead and do this using the area model. So I'm going to go ahead and create my rectangle here. And split this up into 4 regions again so that each one of these has its own place here. This is going to be represented now by 2x. This one here is going to be represented by negative 5. This one here is going to be represented by x, and this is going to be a positive 4. Once again, this turns into a nice organized chart where I can multiply all of these terms out. When I multiply 2x times x, I'm going to get 2x squared. When I multiply 2x times 4, I'm going to get 8x, positive 8x. You could put a plus sign in front if you'd like. I'm choosing not to. Negative 5 times x is going to be negative 5x. And lastly, negative 5 times 4, which is going to give me a negative 20. Make sure that if you do have a negative sign that you include that in there because you will not remember later on. So instead of actually writing all 4 terms down here, I can recognize that I actually have 2 terms that I can gather together, and I'm going to go ahead and do that so that it saves me a little bit of work. I'm going to copy down my 2x squared term first because it's my largest exponent. I'm going to move and I'm going to take these. So I have 8x minus 5x, which gives me positive 3x. And lastly, I'm going to copy the negative 20. There we go on this one here and how that can work. That would be our answer to that problem. I'm going to go ahead and move over here and do this problem once again. This time we're going to be using the distributive property. So I'm going to begin by distributing the 2x to the x. 2x times x gives me 2x squared. Next, I'm going to multiply the 2x times the 4. 2x times 4 gives me a positive 8x. I'm going to go ahead and change my pen. Once again, this is an optional thing, but I think it's a good idea. I'm going to go ahead and distribute now the negative 5 to the x, which gives me a negative 5x. And lastly, I'm going to multiply the negative 5 times the 4. That's going to give me a negative 20. Just like above here, I have 2 terms that need to be combined. So I'm going to go ahead and put those 2 together. I'm going to copy down the 2x squared. Just like over here in my area model, I'm going to have 8x minus 5x, which is going to give me a positive 3x. And lastly, I'm going to end with a negative 20. Okay, so hopefully this has gotten you guys going pretty well on this. We're going to go ahead and flip this sheet over for you. You're going to flip it over for me. I'm just going to remove this out of the way here. I'm going to move this top sheet over, and this is going to flip over here. What I would like you to do now is I would like you to take a moment and go ahead and do these 1, 2, 3, 4. now would be a good time for you to pause the video so that you can try these on your own. Go ahead and pause the video. Okay, so we're back now. I'm assuming that you have paused the video. You have tried number 1, number 2, number 3, and number 4 on your own. I'm going to go ahead and do these. I'm not going to speak while doing them. I'm just going to slip down and do them quite quickly here. Okay, so hopefully you were able to run through these and do all of these. Go ahead and check your work here. Make sure that you've done well on all of these problems. We're going to go ahead and move forward here, and I want to show you how we can extend this beyond quadratics. Although we've been concentrating on quadratics here because that's the concentration of our chapter, we can also do this for all types of polynomials. So I'm going to go ahead and move down here and show you how this can work, where I'm multiplying a binomial, that just means 2 terms, times a trinomial. This is not going to end up with a quadratic, rather it's going to end up with a cubic. And I will go ahead and show you this method here. So this here, I'm going to make this a little bit longer here. So if you'll notice here, I'm going to make this a little bit longer in the fact that I'm going to end up plugging in 3 terms up top here. I'm going to start with a generic length of x here and a positive 3 here. Then I'm going to go ahead and break this length up into 3 pieces, 3 columns here, 1, 2, 3, for me to be able to put my quadratic on top. I'm going to go ahead and put the x squared here. I have a minus 2x right there, and I have a positive 5. You will notice that I have a 2-term polynomial times a 3-term polynomial, once again a binomial times a trinomial, and that's going to give me 6 products that I'm going to have. This is where the area model comes in very nice because it really helps us organize all of these terms. When I multiply the x times the x squared, I'm going to get an x cubed. When I multiply the x times the negative 2x, I'm going to get negative 2x squared. Lastly, with the x, I'm going to multiply the x times the 5, and I'm going to get a positive 5x. Now I'm going to move down and start distributing the 3. When I distribute the 3 to the 2x, that's going to be 3x squared. I'm going to multiply the 3 times the negative 2x and get negative 6x. And lastly, I'm going to multiply the 3 times the 5, and I'm going to get 15. I'm going to go ahead and combine these terms, and I'm going to gather them together as I write them down. It just saves me a step. So I'm going to start with the x cubed term. It's the only one by itself. I have 3x squared minus 2x squared. That's going to give me 1x squared, or also known as x squared. I have 5x minus 6x, which is going to give me negative x. And lastly, I'm going to have the positive 15 here. You could have also written all of these terms out and gathered them together like we're going to do now. Now would also be a good time for you to be able to pause this video. I would like for you to try number 5 on your own. Okay, we're back. I'm assuming that you have paused the video. You have tried number 5 on your own, and now I'm going to go ahead and do this. I'm going to go ahead and use the distributive property. You, of course, are welcome to use the area method as well, but I'm going to use the distributive property on this one just to show you how it works. I'm going to go ahead and begin by distributing the x to all 3 terms. And so when I multiply the x times the x squared term, I'm going to get an x cubed term. I'm going to multiply the x times the 4x, and I'm going to get plus 4x squared, because there's 2 x's there. I'm going to distribute the x to the 7, and I'm going to get a minus 7x. I am now finished with distributing the x term because I've distributed it to all 3 terms, and now I'm going to go ahead and distribute my negative 2. When I distribute the negative 2 to the x squared term, I'm going to get negative 2x squared. Next, I'm going to distribute the negative 2 to the 4. Negative 2 times 4x is going to give me negative 8x. And lastly, a negative times a negative is going to give me a positive. I have negative 2 times negative 7, which is going to give me a positive 14. You'll notice that I have a lot of terms here. Just like over here with the area model, I have a binomial times a trinomial. That means 2 terms times 3 terms. That means I have a total of 6 terms. Just like here with our area model, we have 6 terms. I need to gather these together. The x cubed is all by itself, so I can go ahead and copy it down. I'm going to go ahead with the next largest exponent, which is the x squared terms, or the quadratic terms. I have 4x squared minus 2x squared. That's going to give me a positive 2x squared. Next, I'm going to put together my linear terms, or my x terms. I have negative 7x minus 8x, which is going to give me a negative 15x. And lastly, I'm going to copy down the 14, the constant term. There was nothing else to go along with it. I hope that this video had worked well for you, and thank you for watching.